Good day everyone, good day viewers. I am Sisley Canillo, and today I'll be discussing to you a little introduction about geometric sequence. So let's start. So to better understand the meaning of geometric sequence, let's first consider this table. So we have here the table about the population and food production sequences. It contains two sequences, the total population and the total food production capacity. As you can observe, the total production capacity or the sequence for this total food production capacity is an arithmetic sequence. So as you can see, each term is 50,000 more than the previous term. However, the sequence for the total population does not appear to be arithmetic. Each year, the population is increasing by 7% of what it had been during the previous year. The sequence in the column representing this total population is an example of a geometric sequence. In such a sequence, each term after the first is obtained by multiplying a constant. So in this case, we multiply it by 1.07. So as you can see, the first term, 100,000, multiplied by 1.07 will have a result for the second term. And the second term multiplied by 1.07 will be the result to the third term, and so on. So this is an example of a geometric sequence. So the sequence for the total food production capacity in the table is an arithmetic because each term after the first is obtained by adding the constant amount, which is 50,000, to the preceding term. So let us contrast this with the definition of a geometric sequence. So a geometric sequence is a sequence in which each term after the first is obtained by multiplying the preceding term by a non-zero constant. The number by which we multiply is called the common ratio of the sequence. So let's have an example. So we are given a geometric sequence and we are to identify its common ratio. So to obtain the common ratio, we divide any term by its predecessor. So in this case, we will divide the second term by the first term. So in this, we have the sequence and how to get the common ratio and our common ratio. So in the first sequence, we will divide the second term, which is 8, by the first term, which is 2. And the answer is 4. So our common ratio is 4. To check if the common ratio is correct, you can multiply the terms by the common ratio. So 2 times 4, the product will be the second term, which is 8. And 8 times 4 is the product, or the product will be the third term, which is 32. And 32 times 4 is equals to 128, which is the fourth term, and so on. So in the next example, we have the second term, negative 2 all over 2, which is equals to negative 1. So our common ratio here is negative 1. So that's it, very easy. So let's have another example. How about a problem? So write the first 6 terms of the geometric sequence whose first term is 6 and whose common ratio is negative 2. So we are given here the first term, which is 6, and the common ratio, which is negative 2. So what we're going to do is we will just multiply the first term by the common ratio to get the second term. So 6 times negative 2 is equals to negative 12. And to get the third term, we will just multiply the second term by the common ratio. So negative 12 times negative 2s equals to 24. And the same thing with the fourth term, we will just multiply the third term by the common ratio, which is negative 2. And the answer is negative 48. And the same thing, negative 48 multiplied by the common ratio, negative 2, the answer is 96. And 96 multiplied by negative 2 is negative 192. So this is now our first 6 terms of the geometric sequence. So very easy, right? So that's all for our discussion. I hope you have learned something. Thank you for watching. Goodbye.